Here we have two reactions, two electrophilic addition reactions or conjugated dienes. And what we see here, hydrohalogenation, hydrochlorination, one equivalent. So we're going to be adding only one molecule of HBr. And the other thing that's important to notice is here we have 40 Celsius and here we have 0 Celsius. So we need to pay attention to that because depending on the conditions, we're going to form one product or the other. And I am referring to where is the pattern of substitution. Let's again identify the 4 carbons in the conjugated system, 1, 2, 3, and 4. And in the molecule below, I'm going to say 1, 2, 3, and 4. And so what is observed experimentally is that at low temperatures, the 1,2 addition product predominates. So this is a kinetic control. So at low temperatures, the product that forms faster is favored, and this is the 1,2 addition product. At higher temperatures, and this is higher, we are gonna, at that temperature, observe this we call thermodynamic control of product formation. And what is observed here is the 1,4 addition product. So when it comes to drawing, predicting products, this is what we'll be looking at again. Temperature is 0, so it is kinetic control. I'm drawing the 1,2 addition product. Following the rules that we have learned before, if I am doing the addition here, Markovnikov, remember that we will do that. H is going to go into the least substituted carbon. So I'm drawing, let's do that. The 1, 2. If the H has been added here, I'm going to have my carbon here at carbon 2. And that's where the bromide is going to attack. And we're going to form the 1,2 addition product. I'm going to have to draw it smaller here. So bromine here. Well, that not bromine is actually chlorine, but it's the same. Mechanistically speaking, it's the same. I was using hydrochloric acid, so this is a chlorine. All right, so molecule here is actually symmetrical. So if we notice, that would be, we're creating here a chiral center. Here you had plane of symmetry. However, here you're creating a chiral center. So because you have the carbocation here is trigonal planar, you can form a mix, 2 enantiomers of that plus the enantiomer. Here I'm drawing chlorine on the wedge, so in the enantiomer that will have be on the back side. So I'm just drawing the enantiomer here. We're producing this 2, 1,2 addition products. So we mix up enantiomers. That mixing the same amount of 2 enantiomer, that is a racemic mixture. So a racemic product. Now that, oh, and I'm missing a double bond. We didn't touch that. So we did, this is 1, 2 again. 1, 2, because we're working under kinetic conditions. So 1, 2, 1, 2, and I have a pair of enantiomers. So let's do the problem above. This is higher temperature, so it is thermodynamic control. So what I'm looking at here is, again, you start from the same, and we're going to do Markovnikov here. Breaking the bond over here would give me the following. So I'm drawing a bit smaller so that I can fit things here. So if I form this carbocation, by adding the H here, for the 1,4 product, what I'm going to do is this resonance structure. So I'm going to form This is now double bond here, and I have a positive charge here. And so in that case, again, we will have the attack over with bromine over that. And let's say if we are creating a chiral center now, that is important when you're predicting the number of products. So when you attack with bromide here, you will be doing, now I'm doing this wheel line. Now notice that is a chiral center. Because here you have a bromine, an H, there is a hydrogen, and this chain is different than that. What that means, because the geometry of the carbocation is trigonoplanar, that means that I'm going to have a mix of enantiomers. So here I did the wiggle line to say that I'm doing a racemic. So I'm going to have two products. In one, you will draw, for example, the bromine on a wedge, and the other you will do the bromine on a dash, meaning that is the opposite configuration. So again, racemic product. So here, again, analyzing, pay attention to the conditions so that you'll be able to tell what product thermodynamic or kinetic is favored. And do also check stereochemistry if you are having a carbocation and you are generating a new chiral center, then the attack, remember, here could be from either side of the plane. So therefore, the product will be racemic.